Cool. This is my second LambdaConf. My name is Brad Urani. I'm a staff engineer at ProCore. ProCore is in Santa Barbara, California, where it's nice and beautiful and sunny, kind of like here. This is me on social media. A funny thing happens when you tweet a lot and do a lot of things is you're afraid to change your photo, right? So I'm forever 15 years younger than I am now, and never age. Whoa, what happened? Whatever you did undo that. I love this conference because my mind gets exposed to new and amazing things that I didn't know about. I've learned all about cryptocurrencies and fun things. I also love this conference because I am a CU buff. I did my undergraduate here, so I just have these waves of nostalgia as I walk around campus, you know what I mean? Oh, that's where I passed out in the bush after the frat party. Wow, what fond memories. Are there any buffs here? Yeah, go buffs, woo! I hope your memories are as foggy as mine. But anyway, this is about Ecto. Ecto is a functional relational data mapper from Elixir. This is a math-free talk. If you're there's no category theory or type theory or formal proofs in this one. So if you're all about that and you want to go to a different session, I will not be offended. This is about the intersection of FP and app development, especially web development, but mainly app development. It's about data access libraries and how we interact with SQL from functional programming languages. Like I said, I work for ProCore. ProCore is a company that makes software for the construction industry. If you need to build a skyscraper, we have the software for you that manages your scheduling and your budgeting and all that kind of fun stuff. Here's a picture of our iPad app, right? With plans for, this is a tool we built to allow people to manage drawings on the job site. Here's some men out in the field using this, and I say men because sort of like technology, it is an industry dominated by men without enough females in the workforce in construction. But we do have programs to try to help fix that, like gender gap disparity. We modeled them off some of the tech programs, and we're very proud of things like that. And we do a lot of SQL, right? Our product is mainly a giant web app, right, which runs on a huge Postgres instance that's scanning 20 million rows a second, 30,000 transactions a second. Our database is, actually this slide's a bit out of date. I think it's closer to 10 terabytes now. So this is, it's PostgreSQL, right, on a pretty huge scale. We run on this on what's essentially a supercomputer. It probably costs as much as like a new Ferrari, and this sits in a data center and powers our app. So we're very serious about SQL and the way we use our databases. It becomes very, very important. For instance, here's a page from ProCore. This is a construction budget. This page probably runs 20 or 30 queries, right? And that's highly tuned, highly optimized. Like that gray button up there that's kind of grayed out all the way in the upper right, send to ERP. Just to know whether that button is sort of grayed out or not, you have to do a query with 6 joins, right? Just to decide whether to display that button. So this is what you call kind of enterprise software. I don't like that word enterprise because it doesn't describe our culture, but it does kind of describe the product. So our database has 800 tables in it, growing all the time. And so you can imagine that doing things like this, the choice of our data access library really, really, really matters, right? The sort of details of how the programmers interact with the code that generates SQL, right, becomes ultra, ultra important for us to being able to do this at a scalable level. And this is actually mostly built on Ruby on Rails, right? But increasingly we've been reaching for new tools, reaching for new frameworks, sort of modernizing our stack, and that's where Elixir comes in. So Elixir is a programming language. It is a functional language, right? Immutable. It's got very powerful pattern matching and things like that. It's very, very fast. Everything is, especially if you're used to dynamic languages, like Python and such like that, it is an order of magnitude faster, right? It has wonderful concurrency primitives. It is dynamic. It is untyped, right? I mentioned there's no category theory or type theory in this. In my opinion, those things are vastly weakened in absence of a type system, right? This is a dynamic language. It's created by this man, Jose Valim, who what he did is he created a new language, and the reason Elixir has these wonderful primitives, how it's fast and concurrent, is because Erlang compiles to, or Elixir compiles to Erlang bytecode, right? Erlang is this wonderful language from the 80s, right, made by this man, Joe Armstrong, and it was originally created for telco infrastructure, right? Sort of the challenge was Ericsson, the telecom company, needed to provide digital phone service to basically all of Europe, so they needed something that was massively high availability, right, that basically never crashed, right, and that can handle real-time messaging very, 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 very quickly, right? So Joe Armstrong made this language Erlang, right, with this virtual machine that ran on these telephone switches and basically never ever went down ever. It's incredible technology, but and it allows in a modern day stack, right, running in a data center, right, it allows these it has these incredible communication primitives, right, that allow servers to talk to each other and processes within servers to talk to each other. But it's kind of like an ugly Ferrari. Erlang is like this ugly Ferrari, right, and that's got this amazing capabilities, but it's just like really hard to program in. It's got a very unintuitive syntax, right? So along came Jose and took the Erlang virtual machine, right, with some very kind of Ruby-esque, more programmer-friendly syntax, right, and out comes Elixir, and we have this new programming language. So now they have this Ferrari that's both fast and performant, right? And so then along comes this man, Chris McCord, who makes this web framework, right? It's an MVC-style web framework, ModelView Controller, although they're actually kind of moving past that paradigm. And Ecto, what I'm talking about today, is the data access library that comes in Phoenix. And with this framework, right, you get capabilities that web developers aren't used to having, right, that we didn't have before, which is the ability to make real-time communication apps. So, for instance, things like real-time chat apps become possible using tools that are fundamentally web development tools, right? If you wanted to make the back end of an MMORPG, you now have the real-time concurrency primitives to be able to do that, right? But I'm not really going to talk about a lot of those things today. I'm going to focus in on a very specific part of this stack, right, and take a close look at one of these things that, you know, in the face of all those like amazing concurrency and message passing primitives, can sound sort of mundane, but I would challenge that assumption and say that it's very, very, very important, especially when you're like me and you're dealing with dozens and dozens of developers working on back-end web apps, right, with a lot of SQL, with, you know, where every web page is firing 20, 30 queries, right? The data access library then becomes critically important. Ecto was created by Jose Valim, inventor of the Elixir programming language, and that tells you something right there, that the programming language designer thought it was so important to get the data access component right that he wrote it himself rather than wait for the community to sort of fill in the libraries around his programming language, right? So, this is sort of my personal history through data access libraries. These are basically, these are all Java and C# and Cold Fusion object relational mappers. I've used a lot of these over the years. They're all slightly different. They all have different design philosophies. They all have strong sides and terrible, horrible things that they allow you to do too easily. And Ecto, in my opinion, is the first one that ever got this right. So that's why I decided to do this talk, because after years and years and years of suffering through what I consider very poorly designed data access frameworks, I finally have one that I like. So what are the problems with some of these legacy frameworks, right? These older frameworks. There's this problem called n+1 queries, which, if you're not careful, it's a mistake that you can make generating queries, right? Like, so if you're rendering a table in a web page, an n+1 is where you do one query, right, which gets you some initial data, and then you end up, as you iterate through creating that table, fire a query for every row, right? That's called n+1s, and it's terrible for SQL performance, right? Seeing stars, this is a term I made up for a mistake I see when people using data access libraries, where they indiscriminately select star every time they fire a query. They don't take the time to narrow down their columns, and they end up pulling back way too much more data than they need, more columns than they need, right? Because they didn't think about that, which is poor for performance. Forgotten transactions is one I see all the time. We have if you're not careful on how you architect your application, how you train your junior developers, right? It's very easy them to issue 2 updates and forget to wrap them in a transaction, and then you're not taking advantage of the ACID compliant the atomicity guarantees in your database, right? And Ecto helps with all these, and I'm going to show you why. It helps make these problems less likely to happen by its design. These technologies are fundamentally leaky abstractions, right? Because it's like SQL is like this dog, you know, and you have to treat it like SQL, and you have to write SQL, and you have to think in database terms, right? But then these mappers, they try to these libraries put this like cat suit on it, right? Where it's like you're dealing it with a programming language, and you want to treat it like a cat and pet it like a cat and feed it cat food, but you can't forget it's this dog underneath, and you're doing this sort of like living in these 2 worlds, right, at the same time. And Ecto, I think, gets over this. And these objects, like when you're dealing with objects, you have this is Joe Armstrong's quote, you wanted this banana, but you got was a gorilla holding the banana, right? Because you have this object that represents data and logic all enmeshed into one, and it's doing lazy evaluation of queries, and that makes it becomes an exercise of state management, right? And Elixir and Ecto avoid these things. How does Ecto do this? In my opinion, the designers of this library got 2 things right. First is restraint. They did not over-abstract, right? And that is one of the sins of the past, I think, is that too many data access libraries over-abstract over the underlying database underneath it, right? They try to hide the database underneath, which makes it too easy to make a mistake. The other is explicitness, right? It forces you to define exactly what you're doing, right? At the cost of a little more boilerplate, right? Makes it a little clearer what's going on, which helps readability of the code and other things. So here we go. Ecto is basically broken down. It's broken down into 4 parts. There's actually a 5th, but we're not going to get into that. It has 4 modules, right? A module is just a file that holds functions. Schemas, repos, queries, and change sets. This is slightly more complex than a lot of previous data access libraries, but it's complexity, it's extra complexity, extra things, extra parts for a good reason. So I've got just like a little demo schema here, right? This is just to model attendees at a conference party, right? So you have a conference has many parties, right? So you would have a conference ID on the parties table, and a conference has many attendees, right? So we just have 3 tables here. Party has many attendees. Conference is one-to-many with parties. Parties is one-to-many with attendees. So when we start modeling this in Ecto, this is what it looks like. This is the first part. This is schema, right? So we have a file which represents the party, right? Hallwaytrack.party. It's the name of my app, hallwaytrack. And we're defining the schema, right? Parties is the name of the database table. And we define the schema here. We define which fields are on this table, right? And we define the relationships that this table has. Now, this syntax right here, what you're looking at is Elixir's really wonderful macro system. So this is calling macros, right? They get executed at compile time, which bake in a lot of other functions into this module, right, that get used at runtime. Now, another interesting, and that's why you get this kind of interesting, it's kind of a Ruby-esque kind of syntax with the block helpers and things like that. But you can see that I've defined 2 fields. Now, data mapper libraries typically come in 3 flavors, right? For strongly typed languages like Java and C#, well, let me back up a second. For a relational data access library to work, right, it needs to be aware of what fields are on the table. Typically, this is done in one of 3 ways. A lot of the ORMs for instance, statically typed languages like Java and C# will generate code, right? They'll actually connect to your database, do some metadata queries, and will actually generate code for you, right? That's one way. Then there's this way, which is where the programmer defines the fields explicitly, manually in the model class. And the third way is the purely dynamic way, which is you don't define the fields at all, right? And at runtime, the program will query the metadata and cache that, or not need to know about it in some cases, which is a lot of what like Python, PHP, Ruby, object relational mappers do, right? So this kind of took the middle route of asking the programmers to define the fields. And I really like this route. For one thing, you can define more than one schema per table, right? So it breaks that one-to-one relationship between, like the generated code model, right? Which is like, here's your table, here's the code that represents your table, right? Now what you can do is I can make multiple schemas, some of which hide and expose certain fields, some of which hide and expose certain relationships, right? And by using separate schemas allow you to limit the functionality down to what you need just for the functionality, just for like the feature you're building, for instance. So we can see the parties has many attendees, right? By declaring that in the code, Ecto is now aware of this relationship. It can now do more powerful querying when we get to the query time. Belongs to is the inverse of has many, right? Because a conference has many parties, so therefore a conference belongs to, a party belongs to a conference, right? So that's many to one, basically. And then timestamps is for the excellent. What that does is it creates a created by field and an updated field. And Ecto will fill those in automatically, those timestamps. When it creates and updates records, it will do that for you if you have the timestamps declared. So here we can already see this explicitness, right? Ding, ding, ding. That's our word of the day, explicitness. You're going to hear me say this a lot. And then here's what it looks like when you query, right? I've defined this function, and once again, we're calling Elixir's wonderful macros here, right? So from party and party, we're calling this macro. We're passing it a where condition where we have actual. There's no strings in here, right? It's actually we have this equality statement right in there. We've got conference ID with that little caret in front of it, right? That's a pin, which is it's going to interpolate your variable in there at runtime, right? And then we have a cool select. Now you'll notice this looks like SQL, right? This is why I really like it. Like it looks like SQL, and I think that's a good thing, right? Because in my opinion, for forgetting that you are powering your app off of SQL is the biggest cause of SQL mistakes, right? It's when you over abstract things to the point that you forget the data, you lose track of the database underneath, that performance suffers, right? And then, yeah.
How it's different from entity framework?
Good question. Hold on. I have seen this model in the past, right? Just pull my joke. Has anyone seen anything like this, a very SQL, like a SQL-looking syntax before, perhaps in any of the programming languages? Ding, 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 right? Look at this. Bill Gates, I own GitHub now. I own all your code, right? The idea of having very SQL-looking syntax did come from the Microsoft world. They use a language extension rather than the macro system, right? So Ecto just, in the spirit of trying to, like make up for the sins of the past in these data access libraries, drew inspiration from a lot of good places, including a place where Microsoft did a very good job. Another thing, right, the seeing stars problem I mentioned. Well, if you look at this query, notice there's a select, right? It just kind of nudges you to remember to add a select to your query. What I see in a lot of big code bases that are database heavy is just indiscriminate select star, because people don't narrow down. They very easily forget to narrow down their query and end up pulling back every column in the table. Just by having the select, it doesn't force you to remember. You can still forget, but it nudges you in the right way, right? It encourages you to think about it just by the design. And that's a common theme with Ecto, is it doesn't force you to, like, for instance, wrap everything in a transaction, but the design is such as it makes it harder to forget, right? So seeing stars becomes harder to do, right? It becomes less common. Here's another one, right? Here's for conference with attendees. So once again, we've got this very SQL-like syntax. Now we've got that preload down there. So what Ecto, because Elixir is functional, right? What it's returning is a struct, right? For any query, it's returning a struct. In this case, we have this party. It's going to return a party struct, and that party is going to have an attendees array, a property, right, which is an array of attendee structs. And we use this preload to sort of tell it to hydrate this struct of attendees. So we're going to have nested structs here, party with attendee children in an array, right? And this preload is what tells you when you call this query to hydrate that. Well, the strategy that there are two, like anytime you have that where you've got like a parent sort of child relationship and you want in your app both the parents and the children, you see kind of two general patterns in order to sort of hydrate those models, right, and get your data back. The first is this one, the preload one, where what it's going to do is it's going to run two queries. So when you exit this query, it's going to do select, it's going to get all your parties, right, for your conference. And assuming there are 4 and their IDs are 1 through 4, then it's going to run a second query, an attendee query, right, and get all the attendees. And then it's going to hydrate your structs for you and return those, right? So very, very cool. That's very efficient. It's always 2 queries. Even if you have 1 million parties and 1 billion attendees, it's only 2 queries. The other sort of way you do that, and this is a slightly different way to get the exact same result, is with a left join, right? So the only change to this, from this to the previous one, is that left join line. There's an extra line in there, a left join line. Otherwise, it's the same as what I showed you before. So this is telling, perform this left join, but I've still got that preload at the bottom, which says hydrate the attendee struct. And then, although Elixir doesn't call it structs, that's what it is. But when you run this, right, you've done the same in one query. So I've taken parties and I've left outer joined it to attendees, and you end up with the same results, the same data come back, but in a slightly different way. The only trade-off here is with the left join model, you're pulling back slightly different data. The table that's on the left, which is the parent table, has all its columns repeated for every row. So it's just kind of this trade-off where the left join is one query but transfers more data over the wire, eats a little bit more RAM, versus the preload, which is 2 queries, or how a query per every table you preload, right? But it sends less data across. So it's just one of those classic trade-offs. But Elixir's nice because it gives you both ways to do that, right? To do that parent-child sort of data access. Here's an example of chaining, right? Because we have the full richness of a programming language here, we can build up queries incrementally, but we still don't lose that sort of like essential SQL-ness about the code. So we have from P and party here, we're joining it to attendees, and then we're adding a where, and we're saving that intermediate like built-up query, right? And then, you know, elsewhere, and this could be in a different module, it could be in a different part of your program, where we're doing a from the previous query, and then we're tacking on a select, right? Just to filter down the columns. So you get this rich training. Elixir has a pipe operator that becomes really useful. And so if you really want to reuse a lot of pieces of your query and make things really, really dry, you can, although I don't always encourage that. Here's another one here, right? This is a group by, right? An aggregate query with a group by. So I'm taking the party, I'm joining it to attendees, I'm filtering it by only active parties. We're grouping these, and then I'm applying to the group, I'm applying an aggregate function. So it's like it just looks like SQL, but with the power of a programming language. So we don't over abstract here. We expose the database for what it is, and that's why I really like it. Here's 3 of them together, all in the same model. The previous 3 I saw you, and this is kind of typical of Ecto development. Now, you can drive this up. You can see that there are shared components in all of these, and if you're like me, you always look for ways to like, wow, why should I define the same clause twice? Can't I drive that up? And you can. Yes, there are definitely ways you can. And Elixir makes that nice and convenient, but I don't recommend you always do that. In some cases, in my opinion, copying and pasting bits of queries is actually better than trying to dry up everything. That's a personal preference, but you can have it either way in Ecto. So, probably don't need to explain this to anyone here, but functional programming is about making the complex parts of your program explicit. There's that word explicit, ding, 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 ding. And then that way we haven't lost the SQL while we're building our apps. So when we actually go to query this, right, the third part of Ecto is the repo, right? So we're calling repo.all. So that's my module. The all function is a function that's built into Ecto. And then I'm calling out to my own module that has my query in it, party.forConference, and I pass it a conference ID. This is how we actually run the query, right? So this is the repository pattern. We have a module that represents the database, basically, and we pass the query to that. Now, one nice thing about this is if you've ever used an ORM that uses lazy evaluation, right? This is very explicit about where the query gets run. It's this line that runs the query. Other data access libraries, right, they are lazy. So you build up queries, and sometimes you pass the results out to views and various other things where they get fired, right? The first time someone tries to enumerate them. That has some traps, right? Sometimes you can accidentally call queries outside of your error handling blocks. It makes it very hard to debug, to figure out where queries are being run. This avoids that trap by, that this is the line of code that actually fires the query. And that allows you to sort of make lasagna out of your programs and make sure that all the queries get called at the same level of the stack, which leads to fewer errors, right? Fewer misunderstandings. So here's an example of a controller in a Phoenix web app, right? So I'm hitting this index route, calling my index page, right? It takes a connection, a database connection as an argument. It takes the conference ID. It's destructuring in that it says def index, right? Con is it's passing in the database connection. Then it's got some destructuring right there in the function definition. I'm getting the conference ID out of the query string params that are passed in. Then I'm calling my query, and then I'm going to render. I'm going to render my HTML page. It's all very explicit, not too far different from most MVC frameworks, but just a little bit more refined. This repository pattern, by the way, is nothing new. This is straight out of Martin Fowler, right? It's a mediator sort of pattern, right, between the domain and data. So I'm a big fan. So let's move on to writing, right? This is when we're doing basically our updates and our inserts and whatnot. This is also, I think, where Ecto broke the mold quite a bit, right, in a way that I think is just spot on, and that I think is really, really, really the best implementation I've ever seen. And like I said, I've used a lot of data access libraries, and I'd have to say this is the only one I really, really like. So here's a schema. We've already seen this, but this is a schema for just like a typical user model, right? Every app, more or less, is going to have a user. We're defining the field, the name and the email and the age right there. So pretty simple here. It's just representing our user table. Now, what we do is we're going to break this down into change sets, right? So change set is this sort of new abstraction that Ecto introduces that I'm a huge fan of. So I'm just defining a function here called change set, right? I'm passing it a user struct, right? This is the data that I want to insert into the database. And what we have here is a series of pipes. I'm taking that, I'm piping it to a cast function, which is going to cast all the data types, right, so that they match my database schema. Then I'm piping that to a validate function, which is going to use a very poor regex here to validate that this is a valid email. Don't use that regex in production. This is demonstration purposes only. Right? Then I'm piping that output to another validation function, which is going to validate that my age is in a range between 18 and 100, right? And then finally, I'm piping that into a unique constraint function. So what this is doing is it's telling Ecto, the framework, where the unique constraints are. And when this allows for is better error messages. So some databases don't always have the best error messages. They might throw like a generic unique violation constraint, right? Now, because Ecto knows where the constraint is, it can create a better error message for you. So what we're doing here is describing an operation, realize. That could be, this is when we're creating a new user, right? It's like a web sign-up form. We're creating a new user. Now here's, I put that one on the top, and underneath it I put another one. Imagine your website, right, has a form where you can update your email address. It's one text box. You type in your email, you hit enter, it updates your email. You can see what I've done is I've defined a second change set called update email, where we're just taking the user, we're casting the email, we're validating the email, and notifying the framework of the constraint. Slightly different, but there's a paradigm shift here, right? Because most data access libraries don't work like that. Most of them assume by their design that every time you want to use, for instance, a user model, you're always going to be using the same validations and things like that. That's fundamental to the designs of most of them is you define a model and you define your validations on the model, and every time you save anything that saves to that model, saves to that table, right, you're performing the same set of operations, but real life doesn't quite work like that. When you get to big, complex web apps, every update, every insert is slightly different. And you want slightly different validations. Ecto works that way out of the box. It assumes that every write operation is slightly different, and it doesn't try to share too much of the validation logic, right? So you end up copying a few things, right? It's a little more boilerplate to make things work. But when you do get to the complexity in your app where you realize that you don't just want one set of validations, then this ends up being a huge boon to your productivity and makes things a lot easier, makes refactoring and cleaning up a lot easier, right? So it's just a slight change in design that I think encourages much better SQL practices. So what you do with these things, with these change sets, is you put them in this thing called a multi, right? So a multi represents a series of write operations. So here I've done three. I've got a topic model, right, a party model, and a conferences model. So I'm inserting a new record into topics, inserting one into party, updating one into conference. I create this thing called a multi, right? It's this kind of structure that represents this operation, and then what I do is I pass it to the Ecto function repo.transaction. So as the name would imply, this is going to be wrapped at begin commit, and now you've done these three write operations in one transaction, and you've got this pattern match on whether it succeeds or fails. All right, cool. Well, it's a subtle change, but I think it's a really, really good one because you have to use a multi every time you do a write. That's huge because it makes it nearly impossible to forget your transactions. And that's a common mistake, especially among beginners building apps around SQL, right, it can be easy to forget those things. You miss them in your unit tests, and you don't figure out until later that you have invalid data because your first insert and your second insert succeeded, and then your update failed, and it didn't roll back all those operations. So it's just another little nudge, right? It's another nudge that Ecto gives you to try to remember to do the right thing by making you think about transaction management every time you perform any write operation, which is a small but significant shift in the right direction. Forgotten transactions, right? Oh my God, bro. That's good. There's also like shades of here of like sort of this command query responsibility segregation. Maybe not in the strict sense, but in the broader sense, right? Because we do have fundamentally different sort of paradigms here for reading and writing. We saw that the reads are these Ecto macro calls that look like SQL. We saw that the writes are these change sets. There's something that really makes sense a lot of that in the SQL world, because when you write in SQL, you always write one table at a time. You can only insert or update rows in one table. When you read, you can join. So your results can come back from more than one table. A query can read from as many tables as there are in your database. A write can only write to one database, yet most other data access libraries get that wrong, and they model them the same way. They use the same, model classes, for instance, for read and write operations, but that just doesn't reflect reality, and it leads to sort of this it leads to sort of this mismatch of sort of scrambled code, and when you're actually at runtime, it becomes this exercise of state management, right? So having totally different sort of unrelated paradigms for reading and writing is just one way that Ecto sort of makes your code match the real world and real database usage. Did you raise your hand? No. Oh, sorry. Okay, cool. So we're going from a place, right? Ecto, right? It is a very SQL-esque syntax. You know, what this does away with, you might even call this the downside of this approach, is we have lost the nice English-like abstractions that some object-oriented libraries give you. We are now sort of speaking SQL in our code, right, which is one layer sort of closer to the metal than a lot of other frameworks are, I would say in a good way. But, you know, if you are trying to teach a beginner class, right, and you're teaching beginners who don't know about SQL and about databases, that could be a downside for you, right? It's not quite as beginner-friendly. Seeing stars, right, it just nudges you to think about it by adding that select statement. We've gone from lazy evaluation to eager evaluation, where you really know where your SQL queries fire, and you don't end up in these sort of areas where the queries are actually firing, you know, lazily from the views and different layers in your stack. And that allows you to like sort of confine the actual database queries themselves. When I write Ecto, when I write applications in Phoenix, right, I make all my Ecto queries fire in the controller layer, never in the views, never in the models, never everywhere else. And the design just like lends itself to that. It doesn't force you into that. It just lends itself to that. What's the downside? There is more boilerplate. You probably saw in my code, more copying and pasting, right? Less reuse of certain SQL clauses and other bits, more copying and pasting of some validation. So there is a little bit more code to get the job done than some other frameworks, like say Active Record and Ruby on Rails, which allows you to do most of what you need without any of that, right? There's a slightly more complex mental model here because I'm thinking the reads and writes look different to me, right? It is less dry. It's less readable. Is it less readable? Depends on whether you like SQL or not. I think SQL is fantastic, so I like my code. I like it when my code looks like SQL, but not everyone agrees. Sometimes when I'm like doing the dishes and stuff like that, I'm like sitting there talking to myself. My wife's like, "Brad, what are you doing?" And I'm like, "Insert dish into dishwasher." And I'm like, "I'm speaking SQL, honey." And she's like, "You are so weird." So I don't mind the SQL, right? But so at the end of the day, right, what we have is this sort of like explicitness and performance over convenience. We've got a slightly more verbose framework, but it saves you from a lot of traps that come, especially on apps like we work on, where we've got dozens of developers. Literally dozens of developers. I'm not allowed to tell you exactly how many, but dozens working on one single huge web app, all sharing the same code base, right? This kind of stuff pays off dividends huge in those cases. And by not allowing you to, making it, I won't say not allowing you, by making it harder to fall into traps like n+1 queries, forgotten transactions, and seeing stars and things like that, right? It just makes your apps more performant by encouraging your developers to do the performant thing. It lets the database do what it's good at, right? Encourages transactions, right? It's aware of the constraints, so it gives you better error messages. Testing becomes great. There are fewer side effects. You're dealing with pure functions here, right? So there are fewer side effects. You don't have to do quite as much mocking and stubbing, in my opinion, or in my experience, rather, to write Ecto code. The test suite runs massively parallel, which is really, really awesome, right? So your test suite goes really fast. There are extensions to this, so like if you're using a document store, like you're using MongoDB, right, or if you're using Postgres and you take advantage of like the JSON B type, which allows you to put JSON typed, right, it fully supports all of that stuff, which is really, really great. It also is not specific to databases, right? If you want to, for instance, query Microsoft GitHub, you can now basically use this style like Ecto syntax, right, as a layer over REST. You can write an adapter that translates this into REST calls, and you can use Ecto as to consume sort of whatever you'd like, which is pretty neat. At the end, it's just it's a balancing act here, right? There's a balance between having enough abstraction where you could take a full advantage of a programming language and everything that offers, but not so overly abstracted that you make mistakes in database usage. It's a fine line, and it's the line that I think for the first time I've ever seen, and I've seen a lot of data access libraries, it's the line that they finally got the balance right. And that's why I'm excited about this. That's why I think it's fantastic technology, and I'm really, really excited, and it will help me solve the problems that my team and I encounter, right, with the sort of ORMs and things that we use, why this is such a big improvement. Cool. So I'm Brad Urani. I'm kind of a Twitter addict. Feel free to follow me. Connect with me on LinkedIn. I have a blog, but I don't update it very much. I work in Santa Barbara, California, which is basically paradise on earth for ProCore. right? If you have ever thought about moving to California, but you don't want to move to LA, which is too crowded, or San Francisco, which is too expensive, we have the antidote for you. It is absolutely beautiful. Here's the view from the office. It's gorgeous. We are hiring all kinds of web devs, mobile devs, security, DevOps, machine learning, iOS, Android, Windows, you name it. We're growing like crazy, serving the construction market. And if you're interested, I would love to talk to you. I think since you all have sat in seats a lot right now, I will let you go, and if you have any questions, just come up and see me rather than making everyone sit through all the questions. Thank you very much.